Now, in the next problem, we will try to find out the total wastage because of the page table in the system. Okay, so what is given here? The main memory size is given 64 MB, logical address 32 bits, page size is given 4 KB. Okay, so here you have to remember that each process will have pages. Okay, so better to calculate total number of pages in the memory instead of finding out number of processes and counting their pages. Okay, so you have to draw this diagram. Again, now you are familiar with this diagram. Okay, so CPU is generating logical address, and this is a physical address which we have to convert, and this is a page table. Okay, so we'll solve it step by step. First thing is the size of main memory is given, that is 64 MB. 64 MB, 64 MB, which is byte addressable. This I have told you. Okay, if they have not mentioned, you have to write this as byte addressable. Okay, so physical address is equal to how much? 64 MB upon 1 byte. So you will get, okay, this will get cancelled, you will get 64 millions. So that can be written as 2 raised to 6 into 2 raised to 20. So this will be 2 raised to 26. So what is 26 here? 26 bits. Okay, your physical address will have 26 bits. So you can write here 26. Okay, so this is 26 bits. Now page size is given. Page size is given as 4 KB. Okay, and size of each entry is 1 byte. Okay, so to find out D, what we can do is D equal to 4 KB upon 1B. So cancel this B and you will get 4K. That can be rewritten as 2 raised to 2 or 2 raised to 10. So that will be 2 raised to 12. That is, what is 12? 12 bits. Okay, so we can mention here, you can show in the diagram, D is how much? D is 12. So this is 12. Now from this we can get frames. 26 minus 12 is how much? 14. Okay. Now next step is what we have to do. Next step. Now we got this D, we got physical address. So we can write hence we know that F requires, what is F? Frames. Okay, F requires 14 bits, which we will approximate to how much? To 2 bytes. Why? Because 2 bytes is 16 bits actually. Actually 2 bytes is equal to 16 bits. Okay, so here for 14 bits also we have to use 2 bytes. Okay, so total size wasted in page table will be 2 raised to 20 into 2b. Okay, why 2 raised to 20? Why 2 raised to 20? Because Here, logical address is how much? What is given? Logical address. Number of bits, 32 bits, right? So this is 32 bits. What is D? D is 12. So 32 minus 12 is 20. So how much? We'll get 2 raised to 20, right? So 2 raised to, sorry, 2 raised to 20. So this will be equal to 2 MB. So this is the total size wasted in the base table.